Hi all, welcome to new class. Today's class is derivation of EMF equation of a generator. Let us go through the class. Let phi be the flux per pole in Weber, then Z total number of armature conductors, then P number of poles, A number of parallel paths in armature, then N speed of armature in RPM. Then by Faraday's laws of electromagnetic induction, the flux cut by one conductor is equal to d phi, and that is equal to the flux per pole into number of poles, that is phi into P Weber. So the flux cut by one conductor is, here we have flux per pole, so phi into P. Next is the time taken to complete one revolution. The time taken to complete one revolution dt is equal to 60 divided by n seconds, because we have 1 revolutions per minute equal to n, then in seconds we will get it as 60 divided by n. So here revolutions per minute is n, so while taking the time taken to complete, from here we will get it as 60 divided by n, that much seconds. Then average induced EMF in one conductor E, that is according to Faraday's laws of electromagnetic induction, we have d phi by dt. So here d phi is phi into P, that is phi P, divided by dt is 60 divided by n, that is n divided by 60, that much volts. Then the number of conductor connected in series in each parallel path is equal to Z divided by A, that is number of conductor in each parallel path. So A is number of parallel path, so we will get at as Z by A. Therefore, the average induced EMF across each parallel path or across the armature terminals, capital E, is equal to this phi P n divided by 60 into Z divided by A. So this is the average induced EMF across each parallel path, and this we can write as phi Z n P divided by 60 into A, that much volts. So this is the EMF generated in a generator. So this is the EMF equation of a generator. And for a wave wound, that is for a wave wound generator, this A is equal to 2. So EMF generated is equal to phi Z n P divided by 120, and that much volt. And for a lap wound generator, this A is equal to P, so we will get E as phi Z n, that is here in the case of lap wound generator, A is equal to P, so these two are cancelled, so we will get 5 is a 10 divided by 60 volts. Let us do a problem. A 4-pole DC generator having wave-wound armature winding has 51 slots, each slot containing 20 conductors. What will be the voltage generated in the machine when driven at 1500 rpm, assuming the flux per pole to be 0.007 Weber? So here number of poles are given as 4. So P is 4. Then it is given that wave wound armature. So A, number of parallel path for wave wound armature is equal to 2. Then it has 51 slots. Each slot containing 20 conductors. So number of conductors is equal to slot into number of conductors. So here 51 into 20 we have to do to find the total number of conductors, and we have to find the voltage generated when driven at 1500 rpm. So speed is given as 1500 rpm, and flux per pole, that is phi is equal to 0.007 Weber. So we have to find the voltage generated, that is E, or in the case of generator we can denote it as EG. So EG is equal to phi Zn P divided by 60A. So that is equal to 0.007 into 51 into 20 into speed is 1500 into P is 4, then divided by 60 into A, that is 2, and we will get it as 357 volts. Let us do another problem. A DC generator has 8 poles and 120 slots with 8 conductors in each slot. If the flux per pole is 0.04 Weber, then find the EMF generated when the speed is 600 rpm. Second one, what should be the speed of rotation if the induced EMF is to be 500 volts? Take the armature to be lap connected. So the given datas are 8 poles. So P is equal to 8. Then 120 slot with 8 conductors in each slot. So the number of conductors equal to 120 into 8, and that is equal to 960. Then flux per pole, that is phi is equal to 0.04 Weber. Then first one we have to find the EMF generated when speed is 600 rpm. So N is given as 600 rpm. Then we have to find the generated EMF, that is EG is equal to phi Znp divided by 60 into A, and it is given that lap connected. So here P equal to A, and that is equal to phi is 0.04 into 960 into 600 divided by 60, and we will get 384 volts. In the second question, we have to find the speed when EMF is 500 volt. So this is the first case. Then second case, we have to find the speed when EMF is 500 volt. So from this equation we can write that EG is directly proportional to the speed, that is EG is proportional to speed N. So we can write when EG1 is equal to, when EG is equal to EG1, then N will be equal to N1, and also when EG is equal to EG2, then N is equal to N2. So these Eg1 and N1 are the first case EMF and speed, and these are the second case EMF and speed, and here we have to find the speed N2. So we can write here Eg1 divided by Eg2 is equal to N1 divided by N2. So here we will get N2 is equal to Eg2 into N1 divided by Eg1. That is N2 is equal to Eg2 is given that 500 volt into N1 is 600 rpm. Then Eg1 is, we get it as 384 volts, and after doing we get 781 rpm. So in this case we are doing these types of problems. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.